Right, this is a respiration equation, and what it means is anytime you have a solution that has carbon dioxide and water, some of the carbon dioxide will stay separate as carbon dioxide and water, but some of the molecules will recombine and switch partners. And they're going to switch together, and they're going to come together, and they're going to form this new molecule, which is called carbonic acid. And some of them will come back apart and stay as CO2. Some of them will come together and become carbonic acid. Some of these atoms still aren't happy, and they want to trade partners again. And when they do that, these H2CO3s, they decide that they don't want to be together as a group anymore, and they come apart. And when that happens, we end up with the bicarbonate ion and the hydrogen ion. And the hydrogen ion is the measure of pH. The more free hydrogens you have in any given solution, the lower the pH, the smaller the number on the pH scale. And these arrows tell us the direction of the reaction. And you might notice these look different than other ones because the arrows go both ways. And that tells us that this reaction can go in both directions. And these items will want to form an equilibrium with each other. So that any given moment you'll have the same amount of CO2 and carbonic acid and free hydrogens in a solution. But if you were to add something to the solution, like if we had a container here now, and it's got all of these in the solution, and then we take and we put more carbon dioxide in, which is what we're going to do when we blow into the phenol red solution, what's going to happen is we add more CO2, this entire thing wants to stay at equilibrium. So there's more CO2s here now than all the other species. So as we add CO2, then some of them will come together to make more carbonic acid, and then some of them will come apart and make more free hydrogens. And whenever you add carbon dioxide to a solution, like blowing into it, on the other side, as you're blowing the carbon dioxide in the solution, those free hydrogens will begin to appear. And the more CO2 you add, the more free hydrogens you get because they remain in equilibrium.